Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 105 and the question is 20. It reads, a Mini is travelling southwards at 24 kilometers an hour towards a right-angled crossroads. It is 30 kilometers from the crossroads. A Rolls is travelling eastwards towards the junction at 10 kilometers an hour. It is 20 kilometers from the junction. Write down the velocity of the Mini relative to the Rolls and hence find the closest that they will come to one another. This question, to be honest, is very straightforward, and we've done these questions already, so we'll just go straight into it. Just as a note, by the way, I did a pretty comprehensive video on the theory behind working out the distance of closest approach between two objects. So I'll put a link to this if I can remember it, and if there's no link, just check it out in the playlist for this chapter. So now you draw our xy plane, or Cartesian plane. Then we draw the velocity of the Mini. Now the Mini is travelling southwards, but it is travelling towards the crosswards southwards. So what we can draw here is, this is the velocity of the Mini, and we know that its magnitude is 24 kilometers an hour. So the magnitude is equal to 24. The next thing we're told is that the Rolls is travelling eastwards towards the junction. So the Rolls is doing something like this. So we're going to call this VR, whose magnitude is equal to 10 kilometers an hour. So the next thing we're asked to do is to get the velocity of the Mini relative to the Rolls. So VMR. So mathematically it's very simple, it's just VM minus VR. But the important thing, and I've said this over and over, the crucial thing here is that we realize that R is in a frame of reference whereby it believes it is stationary. So let's just work this out here. So VMR is equal to, now Vm is just in the y-axis or the j-hat unit vector direction. Alright, so all that magnitude is just going to be in the j. So Vm is in actual fact negative 24 j-hat. And the velocity of the Rolls is going to be in the i-hat unit vector direction only, but it's in the positive i-hat, so it's this positive 10 i-hat, like so. The next thing I'm going to do is just add these, and we get VMR is equal to negative 10 i-hat, negative 24 j-hat. That's correct. Alright? Now the next thing we need to do is get the distance of closest approach of the two vehicles. So just once again to analyze VMR, it means that the Rolls is in a frame of reference whereby it believes that it is stationary. So now of course it is actually moving, but as we said before, Einstein worked out that a moving body can consider itself, mathematically can consider itself to be stationary and everything else moving with respect to it, or it can say that everything else is stationary and that it is moving with respect to them. And both, if you treat both, if you try and analyze a situation using both different ways, you will get the same answer. So they're equivalent, essentially, is what I'm saying. So let's just draw VMR. So we said R is stationary, which means that we'll say the particle here moving is M. So it's going negative I, negative J, so it's going in a direction something like this. Alright, so this is VMR. Alright? And do we know any points on that we'll say the velocity vector VMR? And the answer is we do, because it is the velocity of the particle M relative to R. Therefore, all the positions in which M go through, this velocity vector must also go through. So let's just get rid of this here. And what we're going to try and do is get the equation of the line of the velocity vector VMR. So remember, just a quick reminder, if you want to get the equation of a line, you need its slope and you also need a point. Okay, now I'm just going to write what this is. So it's negative 10 i-hat, negative 24 j-hat. Alright, so we need to get the slope of the slope of the line VMR, and the slope is just going to be the tangent, so it's going to be tan theta. Tan is equal to opposite over adjacent. At this stage I'm sure you're able to visualize it, so it's going to be the opposite j over the adjacent I. So it's 24 over 10, or equal to 12 over 5. So you know that m is equal to 12 over 5. However, we also know that there's another way of getting the tangent. And the slope, or the formula for tan is y2 minus y1 over x2 minus x1. where of course we just have two random points, namely x1, y1 and x2, y2. Alright, like so. So just if we can rearrange this formula, you'll find that y2 minus y1 is equal to m times x2 minus x1. Alright? The information which we know, of course, is that m is going to be equal to 12 over 5. Do we know any points? We need a point on this line, and I've told you any point which the particle m or the mini goes through will be on this line. And we're told initially that the mini is 30 kilometers from the crossroads. So this point here is actually going to be 0 I hat, 30 j hat. So if we plug this point into here, into y1 and x1, this becomes 30 and this becomes 0. So if we just rearrange that, you're going to get 5y2, or 5y because the number no longer matters, minus 12x minus 150 is equal to 0. Now just let me check my algebra there. 5, 150, correct. Yeah, and that's correct. And this is the equation of the line of the velocity vector VMR. And the next question you need to ask yourself is, how is that any good to us? And the reason it's good to us is because this will tell us whether or not a point is on that line. Alright? And of course, say if there's any point on the line, you plug in, let's say, x and a y, and you're going to get a 0 if it's on the line. And if the point is not on the line, like for example, the rolls won't be on the line, you will get the distance it is away from it. So let's just resketch our diagram up here, just to illustrate this. So if we draw our xy or Cartesian plane again, alright, so we have the mini up here and the rolls down here. Alright, now we said that the rolls, because we're saying it's VMR, the rolls is in frame of reference whereby it is stationary. And we'll say this is the velocity vector VMR. So the closest that the mini will ever come to the rolls is when this line here is 90 degrees. Alright, so what I'm going to do is, we have the equation, the line of this line. If I plug in a point where the rolls is, which by the way is equal to, it's 20 kilometers from the junction, so it's negative 20 I hat 0j. If I plug this number into my equation of the line, it will tell me how far I am away from the line. Alright? And crucially, it will do it in units of slope. So we know that VMR was equal to negative 10I, negative 24j. Alright? So we need to just get the magnitude of the slope. The slope, of course, was equal to 12 over 5. So if we just get its magnitude, we're going to get the square root of 12 squared plus 5 squared, which turns out to be equal to 13. So what will happen here is, when we put in negative 20, 0 into this, we'll get a positive number, which means it's not on the line. If we divide it by 13, it'll tell us exactly how many units or how many meters we are from the line. So let's just do that. Let's get rid of this box, which we don't need anymore. Alright, so that's 150 by the way. So we need to plug in negative 20, 0. So this just becomes negative 20, and this becomes 0. So we're going to get 12 times 20, so that's 240 minus 150 over 13, and that's going to be equal to 90 over 13, which is the answer given in the book. Alright, so that was reasonably straightforward. Just the point to note, of course, is you must realize that this, when you plug a point to test your point to see how far it is away from the line, it'll give your answer in, it's scaled up, and it's, so in order to get it in meters, you must divide by the magnitude of your slope, or the magnitude vector for your slope, excuse me. Alright, so that was reasonably straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.